REDAWN stands for Reducing Energy Dependency in Atlantic Area Water Networks. The overall aim of the project is to foster the adoption of hydropower energy recovery technology in built water networks in the Atlantic area. So REDAWN aims to improve the energy efficiency of water networks through the installation of innovative micro hydropower technology. This technology will recover wasted energy in existing pipe networks across irrigation, public water supply, process industry and wastewater network settings. The impact of the project will be to help the water industry deliver greater savings on CO2 emissions. That's what we set out to achieve, and that's what we will deliver as we move into a new and a better future for our planet.
Since the inception of the project, we have collaborated with our partners to communicate the project activities and findings to important stakeholders across the Atlantic area. This includes using traditional and social media outlets, via our project website, a wide range of publicity materials, and by attending and organising a variety of events, including webinars and site visits.
Our contribution to the project has several aspects. The objective is putting micro-hydros all over Europe, or at least the Atlantic area. This platform also allows to obtain the green certificates. It's a kind of reward that your country gives you for producing renewable energy. We have done the business model. We have shown which are the key partners, the value proposition to implement this kind of business. We hope that this kind of installation will be spread all over the Atlantic area sooner.
I've been working in the REDAWN project for the past 3 years. This is the first large-scale assessment of hydropower resources in a variety of water network types. What this element of the project did was examined almost 9,000 different sites and assessed how much energy could be exploited by installing micro hydropower within these water networks. So what the project found was a significant energy resource of between 900 and 2,000 gigawatt hours per year if all of those sites could be exploited using hydropower. If all of those hydropower resources were exploited, it could contribute between 2 and 15% of the energy required for water services. So going forward allows policymakers and water utilities to see what the effect of large-scale investment in this technology could be, and shows the role that hydropower could play for sustainable development in water systems in the future.
We are able to improve the water system because with the electrification of the water networks, we have been able to demonstrate that turbines or the micro-hydraulic plants is a commercial technology that could be implemented easily in the operating water networks, and a reduction in the CO2 emission considering the whole water networks of the Atlantic area.
Our work was how to find the best distribution of this micro hydropower plant in the network, which kind of production device can be used in each, which kind of piping and control of the plant is necessary to face the variability on flow rate and pressure. And finally, is the economic benefits that can be obtained by introducing this energy recovery plant.
I worked on the design strategy to select the best machine, and this is a method that considers the variability of the flow pattern within a network. I also produced 2 computer applications, a database containing all the information on a wide range of paths that we collected during our REDAWN project.
What was developed in REDAWN needs to be implemented as soon as possible to facilitate the data mining and collection of the system's behavior in real time, to be possible to act and repair or correct operating rules, to improve the system efficiency, to increase its sustainability, reliability and flexibility for the integration of several optimization parameters towards better future solutions associated with smart cities and smart grid in a near future.
We use the pressure of the pipe with this small pump and to produce energy, and that's amazing. The future application for us is lightning in a crossing, so you can mix this production of energy with the designing of your city. We try a new approach of the energy, and we try to use the energy you have in the ground, in the pipe.
While other work packages focus on the technical barriers, we also need to address the non-technical challenges so the technology can realise its full potential. Some of the non-technical barriers include poor economic incentives, diverse water governance policies, and a lack of support in some organisations for water innovation. I think the outcomes and the recommendations from Work Package 8 will help to raise awareness of policy and administrative barriers to implementing microhydro and highlight how these can be removed in the future.
I am proud that our contributions to these work packages has helped deliver a successful EU Interreg Atlantic Area project.
So, good morning, everybody. You're all very welcome to the final REDAWN conference. My name is Terry Waugh. I'm the lead partner of the project. I'll be hopefully trying to move us from speaker to speaker during this morning's webinar with some experts in the background doing the hard work. It's been a very difficult year for everybody around the world. And naturally, we would normally have been having this conference in person. In fact, we had planned to have it in the very exciting Titanic Exhibition Centre in Belfast. And there would have been an opportunity for those of you, and that many of you who are attending today may not have attended an in-person event. Just a few housekeeping rules before we start. It's helpful if you have your camera turned off during the main part of the webinar. And if you could try to remember to mute yourself as well. If you hover your mouse around the bottom of the screen, you'll see an option to raise your hand if you wish to ask any questions during one of the breakout sessions. You'll also be able to see along the bottom of the screen options to listen in Spanish, Portuguese, or French. This occurs in the main room only. So to listen to the interpretation, just click interpretation and click the language that you prefer to hear in. All attendees are invited to ask questions and to make comments via the chat function. So if I could now just take 5 minutes to introduce myself and the project. I'm the Chief Executive of a small charity from Northern Ireland called Action Renewables. We're the lead partner in the REDAWN project. We employ 22 people, and we are a renewable energy company. In Northern Ireland, the 3 sectors most responsible for CO2 emissions are agriculture, transport, and energy supply. The single largest user of energy in Northern Ireland is the water industry. However, Northern Ireland Water is committed to the achievement of greater energy efficiency and carbon emission reduction in all of its business activities. And for that reason, with them being an associate partner in this project, we set out to try to help them through this project, as have all the partners for similar reasons in their own regions. The water industry is the 4th most energy intensive sector in the Atlantic area, responsible for significant contributions to climate change and reductions in their own competitiveness due to the associated costs. So REDAWN aims to improve the energy efficiency of water networks through the installation of innovative micro hydropower technology. This technology will recover wasted energy in existing pipe networks across irrigation, public water supply, process industry, and wastewater network settings. And that's what we've been working on collectively for the past 3 years. REDAWN, as you've seen in the video, it stands for Reducing Energy Dependency in Atlantic Area Water Networks. It's a 3-year project, and it was funded by the Atlantic Area Transnational Programme. We were awarded almost 2.2 million euros in European Regional Development funding. Now, as I mentioned earlier, Action Renewables is the lead partner in REDAWN. It's our job to simply manage the project, to make sure that everyone is doing what they're supposed to be doing, and to make sure the project is achieving its objectives. The other partners, they're the real stars of this project. They're the real experts. You're going to hear from some of them today, and they're all here today. So I would encourage you all to take the opportunity during the various breakout sessions to talk to them and to learn more about the project. The overall aim of this project is to foster the adoption of hydropower energy recovery technology in built water networks in the Atlantic area. And to achieve this, the project was broken down into smaller work packages, and you're going to hear more from the various work package leaders during the seminar. 2020 has been a real challenge for everybody around the world. In this project, we achieved a great deal in the first 2 years of the project, and we achieved as much as we could during the COVID-19 pandemic. We do have an extension, so it will continue to run through until the summer of 2021. However, we have achieved enough of our targets to be able to hold this event today. I'm delighted that I am now able to introduce Andrew Muir. Andrew Muir is an Alliance Party MLA for North Down and the party spokesperson for infrastructure and finance, serving on the Assembly Public Accounts and Infrastructure Committees. Andrew has served as an MLA since December 2019. Prior to joining the Northern Ireland Assembly, Andrew served as a councillor since 2010, Mayor of North Down 2013 and 2014, and group leader of the Alliance Party group on Ards and North Down Borough Council since foundation in 2014. Andrew, and I can say this because I know him personally, is without a shadow of a doubt a true environmental campaigner. He fully recognises the need for a project like this. So I'm delighted now to introduce Andrew Muir. Over to you, Andrew.
Thank you very much, Terry, for that very kind introduction. Bonjour, hola, hello, and a big virtual welcome to you all from Northern Ireland. I'm very grateful to be asked to open today's event. While we're all very used to these virtual events by now, it is still a real shame you're not able to come in person to Northern Ireland today. For those of you who haven't been, if you like water, you'll love Northern Ireland, especially at this time of the year. It's a beautiful place to live and work, and we pride ourselves on being an open and welcoming place to visitors. Once we have returned to some sort of normality, including the ability to travel, I encourage you to come and see it for yourself. I promise to buy you a pint of Guinness. COVID-19 has impacted on every part of our lives, not just in terms of how we meet, but up to including how we use water. I know that locally in Northern Ireland, our water producer, Northern Ireland Water, has had to adapt by putting measures in place to make sure that staff can carry out essential engineering works. Furthermore, their financial model has changed as businesses and traditional offices use water less and domestic usage has increased as people work from home much more. A lot of these changes initiated by COVID are here to stay, and we need to support our water industry to ensure that it is able to adapt. The issues that REDAWN is seeking to address are incredibly important. As Terry has outlined, if we are to meet our net zero targets that we collectively signed up to through the Paris Agreement, then making our water infrastructure more efficient will be critical. I welcome events such as REDAWN, which offer an opportunity for building networks, information sharing, and learning from best practice of others. I know that there's a huge amount of innovation in the water industry across Europe and indeed the world. In my own constituency of North Down, NI Water is in the process of establishing a hydrogen easier for me to say, electrolyzer as part of its plans to build a 1 megawatt facility, the first of its type in the UK and Ireland, that could supercharge our hydrogen economy. This is one local example of the amazing innovations that are taking place across the continent. For politicians like me, we want to embrace whatever role we can in promoting investments and initiatives such as this. One of my first acts when I became an MLA at the start of last year was to secure agreement of the Northern Ireland Assembly to declare a climate emergency. Having made that declaration, we must follow it up with radical actions to make the change a reality. My party has continued to call for increased investment, not least in the water industry, in order to decarbonise our infrastructure. Not only is this an essential part of our moral obligation to tackle climate change and limit global warming to less than 2 degrees, but it should also be seen as an opportunity to create jobs and help build the new industries of the 21st century. In Northern Ireland, our Department for Infrastructure has recently committed to ordering 100 zero-emission buses, many of which will be powered by hydrogen generated by the water industry. As the countries represented at REDAWN today are blessed with natural resources, including an Atlantic coastline, we should be working together to utilise that competitive advantage to be at the forefront of renewable energy generation. Finally, a further reason that I'm delighted to accept the invitation to open today's event is that REDAWN is a brilliant example of European collaboration at its best. I am a committed European. I believe that the major problems that face us today, including COVID-19 and climate change, respect no borders and must be resolved globally. REDAWN is a perfect example of how Europe can work together through the EU to tackle these challenges head on. REDAWN is funded by Interreg, part of the European Social Development Fund. Northern Ireland has benefited enormously from these funds over the years. My party, the Alliance Party of Northern Ireland, campaigned hard in 2016 for the UK to remain part of the EU. Whilst the clear majority of people in Northern Ireland voted to remain, the majority across the UK voted to leave. Alas, we're now very much still working through the significant damaging consequences of that decision for this small part of the world. It's my sincere hope that although that we have left the European Union, Northern Ireland and the UK as a whole can continue to be part of initiatives such as REDAWN. We do not want to walk away from our global responsibilities that we're making at this point at every opportunity. So thank you for the work that you're continuing to do, and to thank you for the invitation to welcome you all to this conference. I wish you every success going forward.
Andrew, that is fantastic. I sincerely want to say thank you to Andrew. Andrew is a very busy MLA. He's one of the busiest MLAs that we have. And for him to take the time to do this introduction is just fantastic. So thank you for accepting the invitation. I know that you probably can't stay with us for the rest of the conference. You're probably going to have to go up to Stormont and ask some important questions. But please do stay with us as long as you can.
Thank you, Terry.
I think next we have some infographics. They're going to last for about 5 minutes. And then after that, we're going to have our first keynote conversation chaired by Armando Carravetta. So I think we'll do the infographics first, and then I'll introduce Armando. Okay, good. That worked anyway. That's good news. So I'm going to hand over now to Professor Armando Carravetta. He's going to introduce Keynote Conversation 1. It's called The State of the Art and Beyond. And Professor Armando Carravetta is a professor in hydraulics at the University of Naples, Federico II. He's good fun. He's very interesting to listen to. And he was a very grateful host when we visited Naples pre-COVID-19. So Armando, you're very welcome, and I'll hand over to you.
Thank you very much, Terry, for the introduction. I am the principal investigator of the search unit of Naples in Italy, and we were in charge of leading the work package on the design and support tool that are necessary for reducing the barriers preventing the full exploitation of the micro and pico hydropower in water networks. And so I'm very proud to present this, conversation that will include topics concerning the potentiality of hydropower and the present technologies. We are from outside the Atlantic area as University of Naples Federico II, and we are very proud to be included in the REDAWN family. I will be short in order to leave time for the speakers and for the question from the audience. The first speaker is Ioannis Kougias. He is a research fellow at the Joint Research Center of the European Commission, and he will talk about the long-term strategies in hydropower.
So thanks a lot, Armando. Thanks a lot for the invitation to be here with you today. Let me share with you my presentation. As you will see, please let me know if there is any issues with my presentation. As you will see, I don't have any affiliation under my name because I just changed affiliation. I was working for 8 years, almost 8 years, for the European Commission, for the Joint Research Center in Italy, as a policy officer, energy policy officer, including the portfolio of hydropower. Recently, I joined the private sector, so I work for a utility within the Edison Group as a regulation and business analysis manager. I'll try in 5 minutes to present my experience within the EU, but also from the private sector, the short one, on what we can do, what can be done to promote hydropower, but also the synergies that are possible between the water sector and the energy sector, which I think lies in the heart of REDAWN project. So a few words about European funding, Horizon funding for hydropower. This is the latest hydropower technology development report from the Joint Research Center, where we collected some info about the funding that hydro received over the last 1 or 2 years. I would like to highlight that low-head and hydrokinetic project, and I think it is important to underline that their share and their amount has decreased over the past years. So we observed that the interest of European funding on low-head is not anymore in the spotlight, let's say, as it was perhaps 10 years ago. However, there are many technology trends that are ongoing and that are creating a space for activities. First of all, this is digitalization. Hydropower, in most of the cases and in all scales, includes projects that are old. They were built in several decades ago or many decades ago. So we need to digitalize design, operation, maintenance in order to arrive to the next generation hydropower plants. This includes also strategies for risk, for climate change, for the multi-purpose projects. In the European context, retrofitting and upgrading of the existing hydropower station is a priority. Europe has the largest amount of utilized, the largest percentage of utilized hydropower potential, and probably the most old field worldwide. So this is a priority for European utilities to upgrade the existing fleet in order to have the required flexibility in light also of the increased share of variable renewable energy production. Another issue that has not attracted the attention is the water withdrawal concessions. In several cases, concessions are about to end, to expire, and especially due to the liberalization of the energy sector, this creates some complexities. I recently came across this interesting article that from Vogel and others that I encourage you to have a look, because this can add some complexity in the operation of hydropower stations in the near future. Of course, small-scale hydropower still has an important role to play, conduit systems, non-power dams. And I think, this is a personal opinion, I think this could be very nicely done in the context of energy communities, auto producers, net metering, and not only depending on utilities and the investment of utilities. Talking about which, I can't expand on that, but I think it's very different the way the water utilities and the electric utilities see investment. I think that electric utilities needed to adapt and become a little bit more, let's say, daring compared to water utilities that, in my opinion, remain somehow conservative. So for all these interventions, especially concerning conduit systems, and I'm sure that the other presenters will have more to say than me, this is something that we should keep in mind. What it means, hydropower in Europe. Almost 100,000 people in Europe work for hydropower. There are many companies in the UK and other countries, as you can see in this chart. And in short, Europe still leads the R&D and manufacturing of hydropower equipment, although most of the activity takes place in East Asia or South America. Still, Europe remains and hosts main product developers. This is not reflected in installation in Europe, but there are activities to move on, and especially there is a lot of attention on modernization and upgrades of the existing field. I can assure you that the European Commission has considers this as a priority, and they try to move it on. Now, I would like also to mention the EU taxonomy. This is probably not directly related to interests of the UK and Northern Ireland, but in any case, this way of financing will become very soon global, and we've seen that many countries have followed the example of the EU, like China, for example. So this is an ongoing debate about the delegated act following the EU taxonomy act that was regulation that was published last June. So in short, the taxonomy flags those investments that are sustainable under a series of criteria, and this enables the operation of the green certificates or the green bonds and investment on sustainable activities. This will change significantly the way that sustainable projects are financed, and this includes also hydropower and the way the energy and electric and water utilities work. Yes, finally, I would like again to say that the EU is still active in R&D, and I think examples like REDAWN are very good examples of technology development and R&D research, and I want to congratulate all of the partners that work in this activity. Thank you very much for your attention.
Thank you, Ioannis, for your talk. I think that the question will be collected, and then at the end of the talks, we will make a question time for you and for the other speakers. It was a very interesting talk because this we know that the most of the problems that we have for the full exploitation of our technologies for water network come out from political and economic barriers, limitations. So I think that is important, your talk, and after I have also some questions for you, of course. The next speaker, it is Anthony Rinjonneau. He is commercial director of the company Hydroforce, exploiting hydropower for Southwest Canalisations. He will talk about an interesting device proposing reversible pump path technology. So please, Anthony, we are ready to listen to you.
Hello. Hello, everyone. Thank you very much. I wish to thank the organization of REDAWN project to invite me and give me the opportunity to talk about energy in water network. I am convinced that the next century, water and energy cannot be considered independently. With the climate change,
Anthony,
we need to adapt our relationship with water and take into account what kind of energy we used to have drinking water, and how can we have a resilient infrastructure. Just to begin, I'm going to talk about myself. I have 20 years experience in water industry. First as key account manager in water industry company in pipe system, and since 2020 I'm the business development manager for water and energy market for SOC. And personally, I'm very I agree with the environment, sustainable, And I believe in the knowledge sharing and to co-create projects. Now I'm going to talk about my company. SOC is a company in the southwest of France, which is specialized about water system and hydraulic and electromechanical equipment. Aware of climate change and future pressure on the entire water cycle, we support municipality by investing in innovative solutions to improve the energy, environmental, and health efficiency of network. That's the reason of developing the market of water and energy with Hydroforce. So the first experience we had in 2017, we made an installation, hydraulical installation, about a municipality would take the water from a dam at 9 kilometers from the station, and they had they reduce the pressure, but they don't take care about the energy. So the solution was to create and to hydraulical central with pump as turbine. So we made the conception of this installation, electronical, hydraulical, and now the installation, you have some numbers. The production now is about more than 5 megawatts per year, and the installation is the total power installed is about 200 kilowatts. So that was our first experience. So it was very interesting for us and for the municipality, because it's a transversal approach between water and energy. And we can valorize the energy, we can valorize the infrastructure. And for the municipality, it's now an extra revenue for the municipality. And also, it's a change about the energy mix because it's a green energy of water. And it's a local energy. So it is very interesting. And now we want to improve the system, because in general, the hydraulic equipment existing on water network is generally single task, and it's energy aberrant. I explain. Electrical energy is consumed to pump water in order to pressurize in one side, and then we reduce the pressure by dissipating hydraulic energy without recovering it. But the first solution, as the example, was to use a PAT, but we use pump as turbine, but in single task solution. Now we are working about reversible technology, not to use only pump as turbine, but pump and turbine. And we have a patent solution, and we work on the first site in France to install this solution to use pump alternatively in pump or in turbine in the same solution. And we have this pump, and we have a network, hydraulic network in 2 directions for the sense of the water. And we have regulation valve for the security. And we have electronical cabinet to control the system and all the condition, the hydraulic condition in the network. And now we are studying in a site in France now to permit to resolve this kind of solution. You have a resource of water who come from a reservoir. So in general, we reduce the pressure, but we can't take the energy back with the reduction. And also, we can use the same system as a pump. So it's a reversible solution. So this is a picture of the site we are studying. You have a reservoir, and we have a reduced pressure, and we're gonna use the same installation to improve and to use pump and turbine. So it's a solution integrated, and it's a new, we think it's a new step to take the energy in water network. So thank you.
Okay.
If you have some question, I'm going to try to answer it after.
Thank you, Anthony. Of course, we will have questions because you know that many of us are working on new devices and on the application in the network on these devices. And so I think that we will have a lot of questions for you, but just at the end of your talk. Okay. So now we have the third speaker is Enrique Hernández. He is the main partner and founder of the company PowerTurbines. He's selling microturbines in Spain and South America mainly, and in France. He will show us a well-known application for us because it's the pilot plant of the REDAWN project in France. Hello, Enrique.
Hello, good morning to all. Thank you, Armando. I'm going to share my presentation. Okay. Can you see it? Okay.
Yes.
Okay, perfect. Well, this is my company, is PowerTurbines. We are based on Spain, and basically our activity is pad manufacturing. That means pumps used as turbines that we install basically in water networks. Our main clients are water utility companies. So I'm going to focus my presentation specifically on the pilot plan we did for SMPGA in France inside the REDAWN project. Well, it is a small pad with around 7 kilowatts of power that we have installed at the inlet of their treatment plant. On that treatment plant, they get the water from the river, and they make all the potabilization process inside. But the question is that, and it is very common, they receive the water from the river with same pressure, and they do not use that pressure for nothing, because they put this water inside a reservoir, and that's all. So if we go ahead, here we can see the distribution scheme of the company. They get the water from 2 rivers, and then they put that water on the treatment plant. We select one of these plants to install just at the inlet on that point. And they make a water drink cable, let's say, and then they distribute the water to the citizens. So what do we do specifically in that project? Well, first we did a small auditory over the water network. We decided to install at that point because it concentrates a great part of the flow that is used by the company. So it's a good point to install that, because you can find another possible points in the networks, but with less flow. So that means with less energy potential. So usually, in general terms, we always find the most energy potentials at the inlet of water networks or at the inlet of water tanks. In the rest of the network, you can find some points, but usually have less energy potential. Well, the water company provides us the information about the flows and the pressure that arrives to the treatment plants, and we identify which was the typical flow when the plant is working. You can see here on that peaks, and that means that the treatment plant is working, and the typical flow was that one. And the pressure that arrives to the plant when it is working is around 1 bar. So this is the hydraulic resource that we can use to produce energy. So the second part is to select which machine match with this point of head and flow. And in that case, we have a method to obtain how a pump works as turbine. And from that information, we select the specific model that works that flow and that pressure. Well, and with that information, we can obtain predict which is going to be the output power. On that case, 6.8 kilowatts. So it is a small part of the power consumption plant. But well, it's a good energy. So in that case, is used 100% for self-consumption on the same treatment plant. In other cases, we produce more energy than the plant needs, and in some countries, for example, here in Spain, you can sell the surplus to the grid, so you can get an extra economic benefit from it. Okay, and the second handicap, the second problem to install that kind of system
is try to integrate them in the existing infrastructure without modifying or modifying the minimum, and always make it reversible. So in any moment, if you have any problem with the turbine, you have to be able to return to the initial situation. So the initial situation was that the water company received the water from that underground pipe, and then it drives the water to the plant. To regulate the flow, they have initially that valve you can see here is a motorized valve, and on that valve is where the pressure was broken. So here we have one bar of pressure.
Enrique, sorry, try to talk close to the microphone in order to have a better sound. Okay?
Okay, can you hear me well?
Yes, now it's much better.
Okay, thank you. Yes, I was explaining that the water company received the water with pressure from that underground pipe, and then through that motorized valve, they regulate the flow they need to work in the plant. So on that valve is where the pressure is broke without any energy recovery. This was the initial situation. What we did, we suggest to do that mounting scheme, where, as you can see, the original pipe is maintained, and the turbine is installed in bypass with this new motorized valve. So now that valve is closed, so the flow is forced to pass through the turbine and then return again to the main pipe and continue to the plant. With this solution, we eliminate the pressure that comes from the river, let's say, with the turbine producing energy, and the water goes in the same way to the treatment plant. With that solution, we have obtained finally this information. We have the flow to the treatment plant that is the same as the turbine. The head, we can take advantage is 1 bar, the power 6.9 kilowatts, and it's supposed global efficiency of around 73%. So, well, it is another problems of integrating the turbine on the water system, that you usually have to be able to return to the initial situation. So, well, you have to take care about that when you design a recovery plan like this. So, well, it is my presentation. I think it's better if you have any questions about it. I will be very happy to answer all your questions. Thanks for your attention.
And the last speaker is Leonardo Roggen from Brazil, who is a specialist in hydropower and an energy efficiency analyst.
Good morning. Hello, everyone.
Hello.
I'll be sharing my screen. Yes. Okay. So, hello, everyone. Pleased to meet you. First of all, thanks for the opportunity. Such a pleasure to be joining this event. As Professor Armando introduced me, my name is Leonardo. I'm an engineer at IGRA, and I'll be talking a little bit about my perception on micro hydropowers here in the south part of the Atlantic, right? So IGRA is a pump industry located in São Leopoldo, southern Brazil. Our team has more than 4 decades of experience with pump products for irrigation, sanitation, mining, and also water supply systems. Our founder invented the technology behind all of our equipment, which is called the amphibious technology. And it's basically the ability to operate either inside and outside water with the same equipment. And Here I show you an example where you can see a pump, and the motor and the impellers are all aligned, both aligned in the same shaft, and the pumped fluid is responsible for refreshing the motor, and by that we guarantee high energetic efficiency, right? In several ways of application, right? So after decades of experience in the pump industry, we decided to enter the energy market by using the amphibious technology to produce electricity. So just for context, here in Brazil, our electrical matrix, it's very dependent on hydropower sources. We have here today more than 112 gigawatts of installed capacity, with great perspective of growth due to our mighty rivers, right? And the problem is that our hydropower plants are huge. About 93% of the plants have the installed capacity of more than 30 megawatts. And in fact, these facilities are definitely not eco-friendly. So here I show you an example of what used to be a forest, and now it's just, a big reservoir. And it's obviously a huge environmental impact. And you can see it all around the country, right? Another problem is that our country is huge in extension. It's a continental country, and what makes energy transmission and distribution very complicated. And by understanding that how Brazil operates, it's quite unsustainable for the future, we as Ispra decided we found actually a great opportunity to make a difference in the market. So we thought a solution that could be expanding the micro and mine distributed generation in order to use some hydraulic potentials that were once forgotten. And actually, I give an example such as water pipelines in water supply systems. So our solution, the solution we developed, is called the Compact Amphibious Electric Hydrogeneration Unit, which stands for USHA in Portuguese. So it's definitely a integrated solution able to generate renewable energy from different hydraulic sources, right? So the heart of this USHA, of this unit, is the amphibious turbo generator. So as you can see, it's pretty much the same as the pump. So instead of having a motor, we have the generator. And instead of having the impeller, we have the turbine. And here at Ispra, each equipment is unique. We do not produce in mass. So we believe that by using computational fluid dynamic simulations, we get the best efficiency of our equipments. So one of the main applications for USHA is the replacement of pressure reduction valves in water supply systems. In this case, our engineers focus on bringing in a solution that could be able to deal with the demand of the systems. As we all know, in those systems, generating electricity is in second hand, because the main function of the system is to produce and handle water with good pressure. So our technology was built to operate among this variation of the systems, right? Our technology can also be used as run-of-river power plants, and it's actually, in this case, a great case for reduction in environmental impact, because we don't need any civil infrastructure for the generation plant. So we also have the opportunity to gain great elevation potential once our equipment can work completely underwater, right? So getting to the end of the presentation, our technology is also aligned to IoT and the Industry 4.0. We have full control, full remote operational management, full control of the variables of the system, and we also have our data management for maintenance, right? So I think this is it. Thanks for your attention, and I'm open for further questions. Thank you.
Okay, thank you. Thank you, Leonardo. Now I will make a first round of questions. I will pose the question to each of the speaker, and I will ask for a fast answer in order to have the possibility of making more questions. So to Ioannis, the first question is from Angus McNabola, our colleague from the Trinity College. And the question is, any suggestion from your experience how to overcome the conservatism you mentioned sometimes in water and energy utilities in the face of micro hydropower project of this nature?
Yes, I think especially for water utilities, this is a very difficult task because in short, I think the reaction would be go away from my network. I don't want anyone to intervene with my water network. I think this is the mentality in many cases. And also because water utilities are not familiar with this kind of technologies. So in my opinion, the way to deal with that is that conduit systems and mini hydro in such networks should be seen as an energy efficiency measure. So an intervention that lowers the footprint of the utility, and as such, it would be a measure inside the strategy of all utilities to improve their environmental footprint. So I think this is the way I would put it, and this should be the policy framework that will be more effective in my personal opinion.
Okay, I will ask another question later on. The second question is to Anthony Rinjonneau from Angus. Also, this question: what motivated your company to try using PAT? What was the driver force for this initiative?
Je vais parler en français, ça sera plus facile pour moi. Ce qui a motivé, effectivement, on se rend compte que l'eau et l'énergie sont des domaines de plus en plus liés vis-à-vis des collectivités. Et les collectivités ont un potentiel d'énergie dans leur réseau qui n'est pas toujours utilisé ou valorisé et ne savent pas comment l'exploiter. Et lorsqu'on parle d'eau, du traitement de l'eau avec des conditions sanitaires, qui est le premier objectif des collectivités, il faut aussi, demain, on pense qu'il faut prendre en compte l'aspect énergétique. Quel est le type d'énergie que l'on va utiliser? Est-ce qu'on peut utiliser des énergies de récupération? Est-ce que l'on peut rendre le réseau plus résilient, plus durable? Et en même temps, ça peut permettre aux collectivités de générer des revenus supplémentaires en profitant de leur propre infrastructure. Voilà. Et cette expérience-là nous a mené effectivement à nous intéresser au PAT et également à cette technologie que je vous ai présentée, qui est de favoriser à chaque fois que c'est possible des pompes en turbine pour réguler et produire de l'électricité, mais aussi de pouvoir les utiliser dans le sens inverse en tant que pompe. Et ça, c'est aussi une autre manière peut-être d'amortir ou de valoriser des infrastructures. Une station de pompage doit exister. C'est un investissement nécessaire, mais on peut peut-être, à partir de cette même installation, récupérer de l'énergie. Et donc, c'est la proposition que l'on souhaite faire aux collectivités et qui aujourd'hui, on sent que ça répond à un besoin.
Okay, many thanks, Anthony. For Enrique Hernández, okay, in many cases, this is my question, this one. In many cases, water utilities have to make tenders for the installation of micro hydropower. One of the problems for the technician is to make a feasibility analysis of the project. In REDAWN, we try to create a PAT database and some codes for a preliminary design. How could the private company installing PATs help to facilitate the preliminary design of this plant? Because in REDAWN, it was quite simpler because we were in charge of the design. We could try to find the company who could make a better design. But I imagine a private company, a water utilities who has to make a project and he can't find the material to make a preliminary assessment of the recovery that he can have from the project. What do you think, Enrique?
Yes, well, water utility companies in general are a very conservative, it's a very conservative sector. And we have to think that his main business is not to produce energy, is to serve water. So the manufacturers, we have to understand that energy generation could not affect to the main purpose of that companies that it serve water. So I think the way to introduce it in a water company is first develop systems that will be always reversible. So design the system in order to have always the possibility to return to the initial situation. This is why we always recommend to install the turbines in bypass with the existing system that they are using to reduce the pressure, but usually is.
But how can they make a preliminary assessment of the recovery, of the energy that can be recovered and of the income of this kind of micro hydropower?
Well, it is like a general scheme that can be repeated in every company. In general terms, basically the main opportunity to produce energy is basically at the inlet of a water treatment plant and the inlet of water reservoirs. Why? Because on that point, they concentrate a good quantity of flow every day and usually in a constant way. Because one problem in installing turbines inside the water network, in the distribution water networks, is that we have different flows depending on the hour of the day. During the day, a high flow because all people is taking breakfast, taking a bath, etc. And in the night, a very low flow. So in water distribution, you can find opportunities. You can install some turbines in parallel with some big pressure reducing valves, but usually the payback, the amortization time of this project is higher. But if you go to the treatment plants or to the water tanks where they receive more or less a constant quantity of flow inside, it is a good point to install a PAT, because on that cases the payback is very good. It's 3, 4, 5 years, no more.
Thank you, Enrique. And the final question basically is for now. I don't know if we will have more time, but the final question is for Leonardo, but it's also for for Anthony, because both of them proposed a reversible, probably a reversible pump, in order, because also the device from Leonardo is a pump that is introduces in a pipe. So basically, probably both of the equipment can work in a direct or inverse mode. In the case of Anthony, it was quite clear because it was designed to be inverted, the flux. In Leonardo case, it is one of the questions if it is possible to reverse the flux. In both cases, I think that one of the idea is to move this device is also in the peripheral branches of the network, and to have the flexibility of using this device in one direction and in the other. The question is for Leonardo if it is possible to have the inversion of the flux. For Anthony, don't you think that it's necessary to have a model of the network in order to control your system? Because often the pressure reduces in a place of the network that is far from the production place. And so if you want to modify the working of your device, you need to couple the device with a model of the network, because it's not so simple to make a regulation of the whole network and to decide where you have to invert the flux in the system.
Actually, we can, but we at IGRA, we do not treat our turbine as a pump working as a turbine. We believe that just by leading our engineering as a whole new development, we can get better results and better efficiency. So actually the process of developing, it's pretty much the same of a pump, but the simulating and the modeling process, it's pretty different from what's usual for us.
Okay, many thanks. So thanks to all the speakers, and I leave the microphone to Terry to continue our interesting conversations. Bye-bye.
That's great. That's great. Look, sorry for cutting you off so suddenly.
No, but, you are right. You're right.
No, that's okay. That's okay. I particularly would like to thank Leonardo, who I think was joining us all the way from Brazil. It's very, very early in the morning there. So thank you very much for getting up so early, and anybody else who had to get up early as well. So we're going to move on to our first of two breakout sessions, which will go through to 10:30. You've got a choice of 3 breakout rooms at the bottom of your screen. So if you hover your mouse along the bottom of the screen, you will see the little breakout rooms that you can choose from. Number 1, energy recovery. Number 2, economic and policy impact. Number 3, design guidance and support tools. And just a reminder to the hosts of those rooms to record. So over to the different rooms now then.